Okay, so we're going to talk about some of the most stressful cuts that I have ever made. Excuse me. Alright, so these are the openings for the ceramic infrared heating elements. This unit is the coil, which you can just see down there. There will be a sheet metal case around it and a fan that forces air up from the bottom. There's the other ceramic unit. There will be a total of, I want to say it's 3,000 watts of heat pumped into this little drum. So, there she be. And I chose this method because in my tests, the ceramic units got the hottest, but they also took a significant amount of time, whereas the coil got the hottest much, much faster. Now, I was thinking that I could probably use the coil as a bit of a boost and have a fan hooked up to go with it. We'll see. I'm going in tonight because that was a lot of cutting and my ears ringeth. In spite of having earmuffs on, the sound of cutting stainless steel with a diamond blade really goes through your skull. So tonight I'm calling it an end. Here's my motor unit sitting up here. I'm going to stiffen it up a little bit more. I think what I'm going to do is cut some unistrut and make a unistrut frame for it to sit on that was a lot more rigid. So that's it. That's all I did tonight. Didn't do a whole lot. Just figured out my heating. Let me show you my heating elements here. I did a lot of testing, so forgive my test setup. I think I'm going to take this old bread maker and its frame and make a test unit for heating elements, just because I can do it. So here's the elements, and they focus their heat at about this point right here, so it's the hottest a little over 1.25 inches from the center portion. I'm handling them with gloves to minimize the crap that I get on them because yeah, it gets very, very hot. It gets about 900 degrees sitting on top of the surface here. So the way that these will be held in place, and I'm loath to carry this thing around, is they will sit right here on the outside facing into the drum about 1 inch from the bottom of the inside drum, and that will give me 1.125 from the inside of the drum, the inside drum to the outside, or to the point, the focus point of these elements. Here is the temperature controller that I intend to use. It runs a solid state relay, which I really don't want to use, but it seems like it works pretty well, so I'm not going to complain too much. The voltage was a little bit iffy. It didn't really want to turn on at the supplied voltage, so I had to do a little bit of re-engineering, but that's fine. I was expecting it. That's it. That's all I could think of to talk about tonight. Here's the drum. I chucked it into my lathe and ran some sandpaper around it so you can actually touch it now. Forgive the copper rivet, but everything has stainless steel rivets and welds. So I think it should prove pretty robust. But only time will tell. That's it. That's all I got. And I'm looking forward to getting these elements, getting the unit put back together. I'm thinking about stopping and buying some acid and cleaning these frames because I'm starting to feel a little bit more confident, a little bit more like I want to move on to the next step. And the next step is to put it together. I have some high heat wiring, which for those of you who do not know, this is high heat wiring. Now this is a thermocouple, and this high heat wiring is sheathed in silicone with a covering of fiberglass, and I sourced it out of some of the bread makers that I've gotten for the project. Now really, I only needed one bread maker. The reason I got 3 was because seeing how each one is put together and the benefits and drawbacks of each one has really helped the design process. So hopefully I can take what I learned from them and apply it in this situation. So that's it for the night. We're done here. Good night.